a current I flowing here. And B bar is directed like this. So looking at the direction of flow of current, how M bar will be directed along B bar. First we'll calculate what is the torque acting on it is 0. What about interaction potential? It is also 0. So it is minus MB. Minus MB cos 0 degrees. What is the angle between, or why torque 0? According to formula MB sine 0 degrees. This will be how much? Minus MB. There's the interaction potential energy. It is minus MB. What about net force? We know current carrying loop kept in a uniform field. Net force should be 0. So what is the condition for stable equilibrium? Net torque should be 0. Net force should be 0. And potential is minimum. It is said to be stable equilibrium. So let's disturb this ring. I'm going to disturb it. The direction of B bar will be retained as it is. I'm not going to change. Can you guess about the M bar? No, see, it is lying in XY plane. You just take notebook. Say I'm telling this one. Just take notebook. You keep it on table. What all you have horizontal surface. You tilt it. Just make it inclined plane similar to that. So I given a small angular displacement theta. How is the angular displacement? Theta like this. Then will there be any how M bar? M bar now will be directed in this way. Then how the resultant torque? Now the torque should act from M bar towards B bar, no? So therefore the torque will act like this. This is theta. How the torque is set up about this axis. Just instead of showing that tau, no, I'll sense of rotation, let me write here. So this will be much easier. So how was the angular displacement given? The angular displacement was given about z-axis clockwise. And how the torque is acting about z-axis anti-clockwise. So shall I say this is a restoring torque? And what it will do? It will try to bring the loop back to equilibrium position. Tell me, to displace this loop, what is energy here? What is energy, initial energy? Minus MB. To displace this loop, I have to do work, no? Minus MB cos theta. Tell me, like, potential G got increased or decreased? In the second diagram, potential G got increased or decreased? It got increased. It was minus MB. Now it will become lower negative value. It will become lower negative value. Suppose it is minus 40 joule. This will be around minus, select it 25 joule. So minus 25 will be greater than minus 40. The potential G got increased. So from where this increase in potential G came? Excitation did work. So what is work done by external agent in rotating a loop to an angle theta about stable equilibrium position. So what is work done by extra agent? Directly UF minus UI minus of delta U. What is UI? MB cos theta. Okay, this is a work done by an external agent. This much of work is done by extra agent to rotate the loop from stable equilibrium. And this energy now weight has got converted into increase in potential of system. Here, shall I say that more energy compared to initial. There's the initial final. So energy, it is available as now increasing potential. Now I'll release it. Torque will act here. Okay, now again, when it comes to equilibrium position, where does that work done by excitation got converted into rotational kinetic energy of the loop? So again, in the next position, again, when it returns back to the stable equilibrium, again, when it returns back to stable equilibrium position, it will have maximum angular velocity. The loop will have maximum angular velocity. So this is z-axis, no? We'll take it. Okay, from, shall I say this work done by X-ray agent should be equal to I z z dash omega square by 2. Rotational kinetic energy. So can we calculate this? What will be the maximum angular speed as we know moment of inertia? And this is mb1 minus cos theta. We'll get that maximum angular speed. And if you know angular velocity of this loop, can I ask you what is linear velocity of this vertices of this square? A, B, C, D. I think we can calculate linear velocity of these points. So all problems related to now rotation mechanics or circular motion will come into picture. So what is the simplest idea? There'll be torque due to dipole moment. Finish all. The rest of everything again you have to enter into rotation mechanics. Getting this? So try to have this generalized idea first. So like that, what happen? If I give small angle, when do it will be SHM? Theta should be small, no? So therefore, what is the torque acting in this position? MB sine theta. So this should be equal to, so will go for calculation of SHM. So torque equal to, time period will calculate. This should be equal to I z z dash into alpha MB sine theta. So negative sign, why negative sign? Because the torque will act opposite to displacement. So then when you compare this time period, we are getting time period of oscillations. It's a SHM. It's going to execute SHM if theta is very small. M is dipole moment, capital M. You should be careful, not mass here. What is M? M is dipole moment. So the loop is going to execute SHM. So about stable equilibrium, I covered many ideas here. Work them exchanging in rotating a loop to an angle theta. About stable equilibrium position is, there's a formula MB1 minus cos theta. And what about unstable equilibrium? How to define that unstable equilibrium? This is the unstable equilibrium. So we'll take the M bar, B bar. This I'll call the unstable equilibrium. So this is the direction of M bar. This is the x-axis, y-axis here. Now B bar is acting here. Now how the torque will act, not in this sense, will act in this sense. And how is it theta given? Theta is like this. So how the torque will act? Torque will act in the direction of angular displacement given to the loop. You can ask questions, sir, how it is possible? So you just go back to the torque, what will happen, how m bar is, m bar will be in xy plane. How b bar will be like this. So you should curl fingers from m bar towards b bar, no? Then how the thumb will point into the plane of paper. Now the torque will be directed along native z axis. What is the sense of rotation of the loop? About z axis clockwise. About z axis, it'll be like this. The loop will rotate. And how is angular displacement given? About z axis clockwise. How the torque will act also? Will also act clockwise. So here theta given like this. I think I can show only, look at both, they're in clockwise. So therefore it is a, shall I say, unstable equilibrium. So what is the condition for unstable equilibrium? Minus mb cos 180. And what about net torque? What about net force? Will be 0. So what is the condition of unstable equilibrium? Net torque, net force should be 0. Potential energy should be maximum. Then it is said to be unstable equilibrium. Is it okay now? So this is the basic core idea. When torque acts unstable, torque 0 stable, not like that. Net force, net torque 0, it will be equilibrium. Stable, unstable will determine potential energy maximum or minimum. I think this will be very easy for you. If you are able to find out even the potential energy also, with that you can check whether it's in equilibrium or not. If it is MB unstable, if it is minus MB stable, if it is MB by 2, if it is a potential energy acting is MB by 2, then it should be what happen? Not stable, nor unstable. So these are the words what happen, will be using that one. Loop is an unstable equilibrium. So you should immediately notice that the M bar B bar angle. So the time